Good morning, everyone. Welcome to the first session. This session is called Why Do We Do It Like That? And our presenters will be Glenn and Barry. So I guess without further ado, I'd like to introduce Barry, and I hope you enjoy it.
All right, thanks, Dan. So everybody can hear me okay in the back there? They said this room capacity is about 80, sleeps 80 comfortably, so I wanted to make sure you guys are all comfortable back there. Good, okay. So this session we're going to have a little fun with. It's going to give you some insight into why. Mankind, this is a famous sculpture by Rodin. We often contemplate why we do things, and sometimes it's not evident. And so Glenn and I sort of sat together and we collected the common questions people ask us when they're comparing it to other products or other things they've used in the past. And why we do things, we believe we do it for good reasons, but it may not be evident to you. So that's the purpose of our presentation today. And we'll first start off with one for Glenn.
And this is one of the questions that we sometimes get. And all these questions are based on the idea that that doesn't make sense. Why do you do it this stupid way? Are you just trying to be cheap, or are you just lazy? Why do you do it the way that everybody else does it? So all these questions are kind of along that basic premise. And this question is, why aren't you modular? I mean, why do you have a whole bunch of different modules like a historian and IO servers, alarm databases, alarm servers? Why is it all in one? And it's a good question. Are we just kind of trying to be lazy? Well, no, there's a basic idea that we're trying to get totally chaotic and trying to get pieces that don't quite fit is what we're trying to avoid. Everything built into one consistent, coherent product. So this term at the top is one that I came across recently, which really describes this quite well. It actually goes along with the data center servers now, which are along the lines of each server has its own capabilities, but they share all the resources across all servers. So it's kind of like a seamless set of configuration without having a separate storage area network. So this hyper-converged architecture really kind of captures what we do quite well. So this hyper-converged architecture, love the term, very techie sounding. The idea is that every server that we have has all the capabilities. It's not like we have a separate historian in a different box or a separate alarm manager in a different computer. So the basic answer is reduces the number of computers. So you buy one VTScada license, all the features are in there. You can basically enable all of them on one computer. You want to go to a second computer, you can decide that this one handles I/O, that one's backup I/O server, this is going to be my historian, that one's going to be my alarm manager. And as you expand, you can just add more and more boxes. So many years ago, I worked with Doug Reach at GRU, back there in the middle of the room. Thank you, Doug, for, for coming in and listening to why we do that. It's one of the reasons I was told that we won or got the opportunity to replace the existing Wonderware system at their Main Street treatment plant was that Wonderware had so many servers required to get the system up and running, and at the other plant they were running, Kanapaha, much smaller set to do the same functionality. So reducing the number of computers is basically one of the key features of the hyper-converged architecture. So it allows you to combine services into one box or spread them over many boxes as the need arises. The city of Sacramento running our software has actually 30 servers spread across 7 facilities. So works just well, perfectly. Many utilities just have one computer that performs all the same functionality. The other aspect of this idea is that one unit or one installed software is easy for customers to understand. One of our competitors on the project for Sacramento, that was probably a decade ago now, they were evaluating the software. We have a single install means you can install it once. Remember earlier today I was talking about we're trying to solve problems, make it easy for people, because we're trying to empower you to get more out of your time. Well, Sacramento, when they were evaluating, took the competitive product, and they had 20 DVDs that they tried to install. They tried for 2 days to get this thing to install properly. And they went on tech support with the competitor, had to get them in the right order. VTScada, it's one install, you put in your key, the key enables the various features that you have, it's done. And that's basically the thing. Why don't we have a separate historian? Why don't we have those, all kinds of things? This is kind of another example from West Palm Beach. This was the proposed architecture from the existing system. With theirs, rather than having all these specialized servers, this is what it came down to be. No, it's just a contrast to see that the whole system gets simpler if you don't have to have more boxes to maintain, more places to copy your configuration. Fewer computers mean fewer points of failure, higher reliability, and that's why we use this all-in-one, non-modular kind of approach. Next one up for Barry.
Thanks, Glenn. So this is one I get often. Why are our support and upgrades bundled together? Why can't I buy them separate? Why don't you have it like Microsoft, where I have Windows XP and I get patches? So you think about that. This is what we want to avoid. This image captures a train on a silo that's forgotten. That's like Windows XP users. They're stuck, right? They have to move off that OS, buy a new OS, maybe not have compatibility for their applications, and they have to struggle with keeping current, right? I had another picture in there. I was going to show a high-speed train beside that, but I thought the metaphor might have been too strong. Anyways, we want to avoid our customers, who we keep for a very long time, of becoming train solid, right? So you see it. We've seen this image in our installer about all our versions, right? Backward compatibility. We're sort of like Apple in that we're continuous improvement. So every new release contains those features. And one of the things that I see Mark Utesh is in the back there, is with Altamont Springs. You know, one of the things I'll talk about, a brief story with Mark, though. We like backward compatibility of our applications. We like to provide lower risk of disruption. What that means is there's not a big worry in applying a version that's built with compatibility and all our regression testing on every new feature, on every past feature. We invest in regression testing, over 100,000 automated tests in VTScada, so we can continue that approach going forward, right? One of the things philosophically, in the story with Mark, is Mark calls, I think he likes our support. It's okay, right, Mark? It's just okay, right? Yeah. Right, I'm putting him on the spot. But one of the things our customers like is they don't fall into this scenario of, I paid you to get bug fixes, but not version upgrades. So they call, and you work through them, and they go, yeah, that bug is fixed in a later version. Great, you solved my problem. Well, you have to buy that. And they go, well, what am I paying you for? Well, I told you what your problem is. People don't want to know what their problem is. They want you to solve their problem. That's why they're calling, right? And that's why they like our support, because our support group is not to try and categorize your problem to be somebody else's problem. They're answering your questions to try and help you with your problem, right? Or our problem, or the problem, right? That's an important part of why we have that bundled together, right? One of the things we help people with, too, help understand, I like getting beat up by purchasing contracts till they see this. We maintain the support costs. So as a sort of appreciation for people maintaining their support, it's fixed for the duration of their system as they go through what evolution. So I had a slide there I took out earlier, but the Ontario Plant Group last year for Niagara Falls Power Generation celebrated 20 years of operation on VTScada. Never a downtime. They started replacing a Unix Quindar system. That was the incumbent. We were the only Windows platform they considered, right? So running 20 years without a failure. Those guys are pretty smart. They maintain their support every year, and they're paying it in 20-year-old dollars, right? So, but they enjoy it. They love it. They actually coined the phrase, which we may see later on. Some of the, it's probably I prompted Lori when she was going over to the challenge. They coined the phrase, engineers left to their own demise will build screens that look like angry fruit salad. So that's why I told Lori maybe to avoid that on the developers challenge over there. But that's actually why we put the idea studio and some of the things we do, and we'll talk about that later on. Right. And so last kid point there, our versions never depreciate to zero, regardless of age. So it's always worth a discount. Any old version of VTScada, it can depreciate down to 75% or 25% of the current list price of VTScada, right? So it's always worth something. And that's a philosophical discussion that Glenn and I had is, I don't want our product to fall into the dustbin. I don't want to be that train silo that it's better just to forget about it, right? Leave it there, right? So we value our longevity with our customers, and that goes into our designs. Right? Next question for Glenn.
Yeah, it hits on a number of things there. I think we get an emotional attachment to the software. We're kind of funny. We enjoy what we do. We get hurt when it doesn't work right. And we take a lot of thought and pride in it. So that kind of goes behind some of the philosophy, some of the ancillary information that you're getting. One of the questions that we get is kind of like a really good question. Why do we have our own scripting language? Why would you have your own language? Well, the short answer is this cute little slide here of, we don't want you to use an obsolete communication technique or a way of talking. So there are so many language choices. There are over 700 languages out there. Why not choose one of those? Good question. They're obviously looking at when we started in 1986, there were many fewer languages out there, but even so, there were some pretty good languages out there. VB was introduced in 91. 20 years ago, it was deprecated. Java, introduced in 95. It basically, as of this month, they're starting to charge a fee for using it. Lots of security holes known to be found in Java. There's lots of Microsoft-ish kind of things that have come along, Microsoft Foundation classes, C#, Silverlight, .NET, all of which are basically deprecated, obsolete by now. So part of the answer is we don't want to have something that's going to be not around 10 years from now when you're running your system. We need something that we can have and maintain. But it's more than that. So we came at originally looking at this, there were some key things that was required for this kind of problem that we're solving. We're in a domain where we need something that's scalable. Now remember, this is back in the DOS days, 640K of memory, 8088 processors, really constrained for power. One of the things that was going to be self-evident to me at the time is we needed something that was highly flexible, but more importantly also scalable. Scalable in that it had to be very efficient computationally. And that led me to this idea of event-driven or reactive programming. The idea that when something changes, it only affects the calculations that depend on that change rather than iteratively going through all the calculations or all of the subroutines in the system repeatedly. Because you go through them all repeatedly over and over again. As the system grows, it gets slower and slower and slower. With this idea of this event-driven execution, it only goes at it limits by the speed of things changing rather than the size of the system. Combine that with something that I got tweaked on in university with state logic. The idea that there's a sequential operation going on inside of hardware chip design. But it also affects the model of how things work in VTScada or in process control. There's always the state that there's a lead pump, then there's a standby pump, there's an alarm state, or you're waiting for something. There's always this state awareness in the software that's really quite peculiar to control systems. Now, if you take a look at the current web-based technologies, they've got this idea of REST, R-E-S-T. the idea that it's a stateless connection to the server. Well, that's fine for some web page kind of stuff, but in control systems, you really want to remember if it's on or off and react to it. So combining those two things, and with a couple of other pieces to it, we came up with a scripting language that was scalable and had the state logic concept built in. So there was nothing else out there at the time. This event-driven execution has become known as a reactive programming language. There are very few of those reactive programming languages in existence. Of those 700, there's a handful. Facebook has subsequently created a reactive programming language just for the same reason. They need to be able to handle hundreds of millions of users acting to the system at the same time. So it's a technology that we probably were the first ones out there with reactive programming language. But it's a really powerful tool, and that's why we did it ourselves. And you throw in a couple of more things on it. One of the things that we wanted to do is be able to change the program while the system is running. As you know that while running Ontario Power generators, you really don't want to be shutting down the software while making power. You've got over a gigawatt of power running through those generators. Just turning the system off to upgrade it is just not a good idea. So we needed a language that would allow you to change the code without stopping it. The traditional programming software, you actually have to write the code in some text, you compile the code, you stop the program, and you restart it with the new code. And you restart the program, it takes time. So there we are. 3 big things that require the VTScada scripting language. It's a full-featured language, too. It's not just the scripting. The scripting, I think, understates what it is. It's a fully object-oriented programming language. And to give you some sort of scope for what it is, there's 1 million lines of code of VTScada itself written in the scripting language. So half the code is written in a C++ engine. The other half is written in the VTScada script language. The scripting language is pretty powerful. All our drivers, all our user interfaces, all our networking is all written in the scripting language. So you'll see our tags, displays, everything. When you open up the Idea Studio in VTScada and you start drawing things, it's creating code for you in the background. And some of the tips and tricks, I'm going to show a little bit of that. You take a peek under the hood at the pages and see what the code looks like behind those. For the most part, you never have to look at the code. Most people never have to see this code. But the idea is that it's there. People want to know, can they do scripting? Well, yes, you can do scripting, because on top of all that is the ability to override or change the code on the fly. You can add your own pieces to it and enhance it to be whatever you need to be. That's why people are asking about scripting, is because they want to know, if it's not found in the product, can I make it? Can I add my own little pieces in there to make it happen? So that's what we're going for. That's the script language. Inherently, it's becoming an anchor piece of the product. It's not going away. It's there forever. It's been there for 30 years. Stuff that was written 30 years ago will run today in the engine. The code and the language is improving over time. It's not deprecated, and it gets enhanced. There are more features in it than there were 5 years ago, and more than there were 10 years ago. So you don't have to worry about Microsoft deprecating .NET. Now, next question for Barry. Why don't we do it like everybody else?
Yes. Well, why don't you use SQL Server, MySQL, Oracle? Are you cheap? You don't want to pay for a database. That's their, you can see that's their thought bubble pop over their head when you're talking to them, right? So why do you do that, right? So the answer, in short, is a big ball of knots. I've worked with projects with large databases. Some of our large enterprise customers, they have databases that we interface to. SAP, we've dealt with high availability SQL Server, which surprisingly is not that highly available. Well, it's highly available if you're doing payroll. Well, it's down for a few hours. We'll get payroll done in a couple hours. No problem. Running your power plant? Oh yeah, well, we'll just run blind for 2 hours. No problem, right? Not so much, right? So that's why we sort of took pains to avoid the database, central database where we could. And so what it does for us, we looked at them, we evaluated them, right? And one of the key aspects we have with our customers is, okay, reliability. Reliability goes without saying what most people should consider the #1 feature. If I was going to sell you the perfect car in terms of features, if it had leather and it had sunroof and it had great tires, great rims, great number of cup holders, that was the thing a number of years ago, and great gas mileage, but oh, by the way, one day in 28, it just won't start, right? And it can be any situation, it just won't start, right? So we live in Canada, that's unacceptable, we'd freeze to death, right? Got to get home from the mall, right? So reliability is a key feature sometimes people overlook, right? So what we were concerned with on the reliability is a large number of our customers have distributed systems. They like to have a primary and backup databases, right? And they like them to be hot available versus warm or cold standby. So back to that Niagara Plant Group, it's all hot standby. They have testing where they go around and this thing is operational and they just start shutting down servers, pulling the power, and it all heals. One of the features in VTScada that people, maybe Glenn will cover it in tips and tricks. If you have 2 NIC cards in VTScada, 2 machines, it detects and uses both of them. Silently in the background says, I'm going to have a backup way to get to the other machine, unless you block it with a firewall or close it down. But it does that on its own, right? To try and maintain its health, trying to keep its uptime, right? So customers will like these hot backup databases. Well, that would mean they're both active. So the thought process goes back to Rodin thinking about things. That means, well, I'd like to use both of them to leverage the resources. Why pay a whole bunch of money for a big database? Well, remember, we're back considering where we're going to go MySQL, Oracle, Microsoft SQL, and SQL Server. So, well, if you got one and you need a backup one, it's great to leverage both of them. So you can log twice as much, so you don't have to bog down the servers, double up your resources. Great idea, right? So, but then each one is logging, can get into a situation where they're logging independently if the communication breaks between them, right? That's a fallout of that design. So why others don't do that, right? Because you have what's called the bidirectional synchronization problem. So the servers get isolated because your network's down. We're selling you a server, a database, a historian, whatever one you're buying. You said, well, I'd like to leverage it, so I'll put one on each plant. Great. So my plants can run independently. Great. And that restores. They're back up to one another. They get to bidirectionally synchronize. They both had time series of data. They both saw different data at different time. It's not the cold backup being copied onto the warm one. Right? It's a different problem. And some of our competitors mask it. They say, well, when they're isolated, they can't log independently. Or if they're isolated, resynchronization is your problem. Right? I actually see specs that come out like that, and you see the consultants have had customers burnt by this. They're not quite understanding the bidirectional synchronization term, but they know what the burn is. The plants are separated, and people are going to do a lot of manual operations to get these servers back in place, or they've lost the data. Right? So that's why we didn't choose other packages, right? Because they were all had very severe limitations. Right? So we created our own, and it's not file-based. Right? It's actually, as Glenn says, it's not flat file-based. It's bumpy. Right? It's got keys and indexes and all those sort of things. All DBMSs, database management systems, reside in a file. Sometimes the layman doesn't understand. They say, oh, you're using a file-based one. I said, yeah, Microsoft SQL Server, I happen to notice when it's installed on your computer, it's either in RAM or on file. That's the only place it lives. Right? It doesn't live in this magical Ethernet. Right? And ours is optimized for a time series of data versus a generic database management system. So what that means is, if you've worked with Microsoft SQL Server or other big servers, they can take blogs, they can take memory records, they can take combination of data images, all different types of data types. And so therefore they have to set up keys. Anybody who has set up a database before, you got to set up keys, set up foreign keys, set up your tables, set up your relationships, set up your indexes, set up maybe stored procedures. All these things you got to set up, right, to make it run optimally. That's because the data can be varied formats. VTScada, it's time series data. We know what it is, right? We know its architecture. Therefore, it's optimized for maximum speed out of the box. So what people like is when they open it up, it just works. You could probably have SQL Server do that if it was optimized for just time series data. Some of our competitors license third-party databases, and they optimize them for that. They have to charge you a very big license price to cover that third-party product. And you have to deal with the problems of that third-party product maybe being obsolete or changing later on in life, right? So that's how they handle it.
Next room.
Next question for Glenn.
I'm just going to add on to Barry's comments there about these, the VTS database. We also talk to Oracle and SQL Server and Store Historian there. So it's not like we can just use our own database, but we recommend that that's at least one of the machines is running that, because no one can shut down our database on the machine and or cut the network to your historian or your SQL Server. And we found that basically our optimized database runs about 5 times faster than SQL Server for time series data because of our optimization, and takes up about 1/5 of the disk space as well. So that's a little more on that SQL Server bit. How are we doing for time? You're asking about version control. I guess, why do you do this version control? Can't I just save copies of my configuration somewhere else? Can I just use a different version control system that's commercially available? Well, let's go back and look at the, why. Well, reliability is the underlying key pin of this. Reliability says that you don't want your car not to start 1 day a month. So this integrated version control, Alan likes to refer to that as the oops button. It's the way out of your problems, that it keeps a complete list, if you don't know, of all the changes that have been made on every machine in the system, so that you can look at not only who did what where, and you can roll back those changes if it's a problem. So great tool, but it's kind of an incidental spin-off of what the real reason was before this. It was initially developed because we had this idea of keeping things configured and not losing control. So our older model dates back more than a decade now. Prior to version 10, we had this, what we call the configuration manager. And that was a server on the system that issued, we call it locks, to pieces of code. So if you made a change, you contacted that server, it granted you the ability to change a specific page or something on the system. It was all transparent to the user. It was great until we started getting into these cloud-based systems around 2000 or so. And we started getting what we refer to as hosted, but they're cloud-based systems. And we had many, many users configuring these systems 24/7, because there were users all around the world getting access to these systems, adding more tags and so on. And what we found out, if you wanted to upgrade or do any maintenance on that server that was the configuration manager server, you keep all the operations running. But if you take that machine down, you could no longer start configuration on something, because there was no machine around to give you the lock. And this is basically the philosophy of the centralized version control systems. Centralized version control systems like the Microsoft SourceSafe,
yeah.
and SVN is one that we use internally in our development network. Great systems, but there's a newer technology that came around called distributed version control. So this distributed version control allows every machine to have basically a copy of the entire history. And so that, Barry's got a great slide that of him with the map on the seat back flying across the continent, and his laptop opening, making configuration changes on the laptop. And the idea is that you can be totally isolated from the network. you don't have to have your configuration server open. The idea that every machine is capable of seeing all the history, making changes independently, and when they come back together, when you land, all the changes get merged back together. So this is the modern way version control systems are done. It was done to handle the case where the configuration server is down. I can keep a 24/7 system up and running and configurable while the system is still fully operational. So what spun out of that is we now have this GUI that allows you to get visibility into all those changes. That wasn't the initial intent. What we sell as the, here are all the list of changes and you can roll them all back, that's just an incidental, wouldn't it be neat if we could give people insight into what's changed? Because now they can see what went wrong. We can make them roll back and change those things. That's just the gift that this thing gave us. So it wasn't because of what we sell mostly, but why we, or how we sell it. It's the other problem of keeping the system online all the time, which has really driven the whole architecture. And at some point we were selling this additional add-on view into the system as a, an add-on or an extra feature which you could purchase. Found that nobody was purchasing it because nobody really understood what it was. So I said, this is too valuable to us for people not to have. So we just included it with every package that's available. So people can now use it in every copy of VTScada. So.
And they love it, as they talk about that's one of the greatest features they had. It's like we were trying to give away a laser for people that didn't understand why they needed a bright light to shine in a straight line, or why they needed a CD or optical disc. So it was ahead of its time in some regards. We could call it blockchain for a configuration if we want to be IIoT configuration. Right?
It's not too far off.
No, it's not too far off in the blockchain metaphor. Right? Yep. So why integrated drivers? Rephrase, why not just OPC? Again, I hear people say, why don't you just use Matricon? Why don't you use Kepware? Just pick any product, right? Use it. Well, this is the metaphor. We wanted to avoid getting our hands tied behind our back, right? That can happen, right, if you're beholden to other products. So the reason why we want to integrate drivers is it's a core SCADA element. Supervisory control and data acquisition. So if you high vote the data acquisition as something else, so you just called a SCA product? Don't know. But it's a core element of a SCADA system. Why? Because it's subject to evolution by others in terms of on the hardware. Trihedral doesn't sell hardware. We're independent. So if we were Rockwell and had our own hardware devices, of course we'll keep them lockstep. If we're a DCS, we could do so as well. But we're not. So we have to talk to other people's hardware equal or better than the manufacturers do. Right? So we want to be able to control that. One of the big things we want to be able to control is if the customer or the vendor makes changes to the hardware in terms of bug fixes, enhancements, or obsolescence. We talk to obsolete equipment. Aquatrol, right? We go to our driver's list. We talk to the Motorola Intrac 2000 system. I had an engineer from Motorola in Israel sat in our office when I was a young engineer and told me we couldn't write that. That was the greatest motivation I had to write that communication driver. Him telling me I couldn't write it. Right? We couldn't write it because they had obsoleted that so long ago. They had no one to support it, no one to help us, no one their library's brother. There was one little problem though. All the lighthouses in Atlantic Canada were using Motorola Intrac 2000, and they had to send people out to maintain these things. And they couldn't have any SCADA system on them. So the Coast Guard really wanted us to be able to communicate to those to solve their problem, because the lighthouses fail when the weather's bad, and that's when they most need them, right? Because the ships need the lighthouses when the weather's bad. That project actually worked so well, if you see some of our slides about the things we've done, we actually went on to take over a lot of Coast Guard work. So actually we do almost all Coast Guard ships on the eastern coast of Canada, right? Because we had control over the drivers, We replace the Seiya Brown-Boveri devices and those sort of things. So you got to support the evolution of hardware, right? You also need high performance. Drivers, especially in today's age, I/O is cheap. So they want to bring in more I/O all the time, right? You need to have the performance of your drivers controlled by you and not beholden by maybe this is some OPC Foundation class, this is some update, whatever. We need to be the one-stop shop for that, right? That leads into, we need the ability to diagnose them at a low level. Now, I don't know if any of you have attended any of the scripting courses. One of the things you'll see is our debugger. We've got a profiler. We can trace all our drivers. We can see down to the byte level what's going on in our drivers, right? That's pretty rare, right? And we do that so we can support them, right? And support our customers. And we also need to ensure fault tolerance. When you're in control of the driver code, you get to understand why maybe it'll only work with one port at a time, right? So you notice in our drivers, COM ports are separate from the driver code. Versus if we took a library from somebody, we may not have that ability to separate that out, right? We want to do that because COM ports fail, or COM ports move over machines, or nowadays, you don't have COM ports on laptops. You have IP ports, and you have multiples. And you have multiple paths. One may be over the network in the plant. One may be over cellular, right? So on the shipboard systems, we used to have Allen Bradley Data Highway Plus, and we had the Allen Bradley Data Sidewalk, which was RS-422. We supported both of them simultaneously. We couldn't get that out of RS links, so we used that with our native drivers, right? And lastly, you need to reduce the complexity for the customer. The more things they have to install, back to that ball of knots, is the more possible ways it can go wrong, right? We know I have customers that have, we do support OPC. We have OPC server, OPC client. But we get calls on customers in the configuration of other people's software because it's not seamless in the setup, right? So we've got some time on these. Well, how are we doing for time, Dan? We're coming up to 3 minutes. Yeah.
3 minutes left.
No, we stop at 11:40. 10:40.
10:40.
We got 3 minutes left. Right. This one I can go through pretty quickly. And it comes up often among our existing users. Why can't I have my feature that I just requested today? What's taking so long, right? What's this gated development process? Why are you doing that? Yes, we don't want to be hanging by a thread. So is our answer, but it gets more detailed, right? Quite quickly. So it has defined stages. And so anything people ask of us to add into the product, and of which the list is quite long, we go through and said, okay, what problem are you trying to solve? We're trying to do requirements capture, right? Trying to define the problem as best we can, right? And then there's a high-level design, right? What a review of that, architecture of that. And in that high-level design, a question's asked. And it actually comes from a comment from Steve Jobs. Sometimes knowing what to leave out is more important than what to put in terms of regards of features, right? Because complexity has a cost. It has a cost in maintaining, it has a cost of reliability, right? So if a feature can be accomplished by another feature or a slight variation to that, you should take some thoughtful design behind it. Glenn's term he likes to use is eloquent design, right? And maybe have it serve dual purposes versus just quickly throwing things at the wall, hoping they stick, right? The analogy I use, I was going to bring up a slide of the cockpit of like a Boeing 747. You take a picture of that and there's 1 million dials and gauges. Well, they're segregated into compartments. But when you first look at that, it looks overwhelming, right? Or in VTScada, one of the things you may not notice is you open the Idea Studio and you click on an analog and you're going to draw, or you click on a widget on the screen. It brings up your widget tools. It's like a mechanic. Or I click on a graphic. I'll say, okay, I click on a graphic. It closes the widget tools and opens up the graphics tools. It would be the same if you were a mechanic and you put your hand on a metric bolt. The metric drawer would open. You put your hand on a standard bolt. The metric drawer closes quietly and the standard drawer opens up, right? So it's trying to make things intuitive for you, right? So with our gated development process, And another thing we have noticed, besides unit testing, is we have integrated testing. So there's a test harness built in the VTScada. There's also those test tools. You get code coverage. You can see every logical path any code took in VTScada. These are things that most users don't appreciate or understand, but in real life, they make the big difference in reliability. Right? And when we say, combination of extreme programming and waterfall, extreme programming, all code is reviewed by a second developer. They sit down and review each other's code. Right? And nothing makes for good quality work knowing that everything you do is going to be reviewed by a peer. Right? You guys are going to write a memo or write an email. I'm going to hand it to your peer next to you, and he's going to read it. Or you're going to fix up your grammar. Right? You're not going to have any spelling mistakes, those sort of things. So our code's important. It does important things. So it's important that it has a review and quality checks on it. Right? And to help with that, we have automated systems as well. SVN, as Glenn mentioned, it builds into our code environment. So I think I can stop there. What time? 4 minutes? Okay. Why care about structured architecture? All right. Obviously, the infant's very upset with the spaghetti on his head, but he put it there, right? Obviously. Hopefully the parents didn't come by and put the spaghetti on him, right? So you may have seen this image before, our layered architecture in VTScada, right? And actually not going to put too much more PowerPoint up on that, just it's sort of self-explanatory. So as Glenn mentioned, there's our C++ engine at the bottom, and there's VTScada script. We couldn't, when Ralph put that graph together, he didn't want to make them as two complete layers, but as Glenn mentioned, that VTScada script is running about a million lines of code. The other million is about C++. So the term in the industry, and our product, VTScada, encompasses those. The term in the industry, in the software industry, is very eloquent. It's called eating your own dog food, right? So Trihedral's VTScada script is used by Trihedral's own developers and our engineers. We're the biggest users of our scripting language, which is somewhat ironic if you consider Microsoft pushing .NET. Microsoft products were all using C# and other things. They were actually using .NET. They're pushing people to use it, but their own products weren't. Trihedral's completely different. We're using our own products, right? And then we have the VTScada layer that the users encompass, right, in terms of drivers, alarming, internet. And then we have these two other things, OEM and the customer application. We put those in so that customers, users, OEMs weren't worrying about which file they copied in at the last moment, right? The thing's loaded what's called late binding, right? So it's, again, to maintain structure to customers. Most people may be oblivious of that. They may go from VTScada to the customer application. But our OEMs and SIs know the power of having that layer that they can put things in a reusable fashion. Back to what we said before, all these threads tied together, we're thinking is we're going to upgrade VTScada, make it easy for customers to upgrade VTScada. It's not going to break things when they upgrade VTScada. Well, what if the customer's got an OEM layer with a whole bunch of customizations copied in? That doesn't work, right? So you need that layered approach so that you maintain that ability to upgrade the customers without breaking their customizations, right? So that's why we do that. Right? And I think we'll stop there. There's some other smaller ones we can go, but given our time, and I guess any questions? Doug. Well, thanks. I mentioned to Chris, the first image was Rodin, the thinker. There's another famous sculpture of Rodin, the thinker, at the gates of hell. We didn't want to really put that one up to make people think that. But it's, for us, it's always making good decisions on these things has lots of things you have to consider, right? Even developing new features for some of our customers, they may not understand this as we want to make this forward compatible, future compatible, right? Because what we're going to write, we're going to support forever. So as Glenn mentioned, when we started in DOS, the DOS programs or applications you created in web, which was still the same product, you could now run in VTScada. We didn't deprecate any of that. Right? If you'd started it in VB, which didn't exist back then, or BASIC, they wouldn't run. They're not around, right? So it's that long-term plan or thought that we find not keeps us awake at night, but it's a key consideration in our designs. Right? And we have lots of discussions back and forth on features and on those sort of things. Any other questions? Ron? Yes. Ron asked, is the VTScada scripting language, is it sort of function static, or does it add functions over time? Glenn can talk to that, but.
Yeah, you just answered. It's
Yeah,
fine.
yeah.
And it's not only just the functions list that extends, but actually the language features. There's different types of syntax and new capabilities in the language that are evolving over time. But all the old things are still there and still maintainable.
Yeah, so we're designed, we're SCADA focused. It's not software for banking. It's not software for a web page, right? So, you know, one of the projects I worked on was the first DAG, or what we call lower level function, was a TCP/IP port. It was our first application using TCP/IP, right? Later on, we'll probably have ports for IoT, various things. As these things, and then we'll support them until such time as Microsoft or the world decides that that's deprecated, but we'll just keep it in our product. Because we don't have to pay licensing fees. This is an interesting tidbit. Windows 10, Microsoft operating system. I was going to show images of, you know, the CD drive and the floppies and all those sort of things, right? DVD drive. If you buy Windows 10 from Microsoft, it has no DVD drivers in it. I found that was interesting. Because they licensed those from the hardware vendors. So they lowered the cost of Microsoft Windows 10 because they're competing with other low-cost operating systems, right? And you only get the device drivers that are loaded from the hardware vendors. So if you buy from Dell and it's got a DVD drive, we get the DVD drivers. It's always third-party stuff. So if your core SCADA system was dependent on DVDs, Microsoft decided you don't need them anymore. You got a bit of a problem, right? Or one on there on the alarm notification, telephone API, alarm notification for a lot of water wastewater utilities. The VTScada alarm notification TAPI works really well, right? That's because it's not Microsoft's, because Microsoft's broke. Because Microsoft decided that no one's using voice modems anymore. Try and buy a laptop with a voice modem. Try and buy a server with a voice modem. So you get products like Win91, where you'll sell a $1,500 dedicated telephony modem. VTScada happens to work with a $65 or $50 modem that works over USB. That's why, because we thought about that and we didn't get beholden to somebody decided that you water, wastewater guys, modems are gone. You don't need them. We're going to take them all away from you, right? You're not going to be so happy, right? Anyways, any other questions? I think we're probably wrapping up, Dan. Sure. So if they're looking at purchasing VTScada in the next few months, they have an asset data management system, and they want to see if they can tie the data between, or there's any concerns of tying the data between that, which is integrated in VTScada, the historian, and their asset data management. Is that, I phrased that correctly? Right. So the answer to that, besides, there's interfaces, open interfaces in the VTScada, and Glenn's going to probably talk about them, or DevRaj actually, shortly, about ODBC, SOAP, XML. But to make it even simpler, one of the historians you can have in VTScada could be SQL Server, MySQL, or Oracle. So you can log it in that historian. Right? Having said all that, that's not the entire answer to your question. That just says the interfaces are open, and we don't try and ransom you to your data. Right? How they interpret the data and what keys they need is a thing that you may have to consider. Right? So it'll depend. We've done interfaces to SAP. And when we did the interface to SAP, we had to have what's called foreign keys to the SAP system, right? So we carried around stuff that the SCADA system didn't need, but SAP needed to understand what the context of our data, right? So it's available. It'd be no different if it was in SQL Server. It's just how do you get it, right? Okay. As a sales guy for that, I just say yes. Yeah, he's from Alabama, so he's got a straightforward answer for you.
As the guy that has to make it work, it's not plug in and play.
Yeah.
No.
Okay.
There's
Any
some
more
work to be
questions? I
done.
think we got to wrap up and let the next group of sleepers get in here.
All right. Remember to fill out the evaluation form. Thank you for coming. I hope you enjoy the rest of the day.